like that. Angstrom. Is that right?
Hold on.
Angstrom. And what? Where do you use that measurement?
Not in everyday life, that's for sure.
Surveyors use it?
Wavelengths?
Surveyors use it, do they?
No.
No. No. So it's got nothing to do with geometry then, has it?
Wait a minute. Did you just imply that if a surveyor doesn't use it, then it has nothing to do with geometry?
No. We're trying to measure the shape of the Earth, aren't we?
Wait a minute. You said it has nothing to do with geometry. Why'd you say that?
We're going from a vertical to a horizontal, right?
Yes. But define horizontal.
Perpendicular to vertical.
Okay, define vertical.
Parallel to the horizon.
The horizon where you stand?
Pardon?
But the horizon doesn't stay in one place if you move.
The horizontal is parallel to the horizon.
But the horizon is below eye level.
It's parallel to the horizon.
Horizon is a circle.
Horizontal is parallel to the horizon.
I heard you. Why do you keep saying the same thing?
Because you seem to keep thinking it's something different, right?
No, I hear what you're saying. It just doesn't make any sense.
Why?
Because I'm about to ask you a question about it, but you keep saying the same thing.
Okay, go on. You're going to ask me a question.
So the horizon is a circle. How do you make something? How do you make a line parallel to that? The horizon is a circle.
Right. Okay. Well, how does it end up being parallel to horizontal then? How does that work?
I would love you to explain that. That's why I'm asking.
There you go. There's one. Definition of horizontal, Merriam-Webster.
Okay. Why do we care about this definition?
Because it's a definition of horizontal. Didn't you just ask about horizontal? Isn't that what you're
Okay, well,
let's
use definitions then for surveyors instead of something generic like what you have.
Horizontal.
Okay, there's some better definitions from like actual surveying contexts.
For horizontal.
I saw it the first time you did it,
yeah,
and then I posted you something better.
Oh, something better.
Yes, from civil engineering.
A surface tangent to a level surface at a given point called horizontal surface at that point. Hence, a horizontal line is right angles to the plumb line at that point. Well, that's a
little bit better than what you gave me.
Isn't that exactly what I said?
No.
Why? What did I say?
Where did that definition say horizon at all?
Just because you didn't you don't think it's parallel to the horizon.
I'm just saying that your definition is different because this one doesn't say.
It's all of the definitions, isn't it?
The definition that you said that you claimed was the same as this one I posted obviously is not the same because your definition included the word horizontal.
Place, is it?
So then why did you say it was the same?
It's a different
you just said
definition.
Wait a minute. You just said it was the same as what you just said.
Horizontal is the same, isn't it?
You just said that
you're saying the horizontal's different.
You just said that.
Is the definition different?
You just said that your definition that you gave me was exactly the same as the
horizontal is the same.
Hey, how about you make a promise not to interrupt when I'm talking?
How about you tell me not to make promises?
No.
There you go, here's another one. Horizontal line. Descriptive geometry and drawing. Constructed line. There you go, that's what a horizontal is, isn't it?
So what about my definition that I posted?
Perpendicular to the vertical. Yeah.
Okay.
Yeah. So
And then what about
we're
the second
sorted. I
line?
mean, we're not on a different page here. You've got a vertical and then you've got a horizontal, right? The difference comes when
Yeah.
you decide you want to divert the level from the horizontal.
Well, that's what this definition is.
Yeah.
When you move to a different point on the surface of the Earth, then you will have a different line. And since you're a fan of using definitions, then you have to abide by this one that I posted.
I have to abide by your definition of horizontal. Yeah, that's, horizontal's fine. It's perpendicular to vertical. I'm going with that.
That's a little too vague.
What?
That's too vague.
It's too vague, saying it's perpendicular to vertical.
Yeah, define vertical.
Perpendicular to horizontal.
That's circular logic.
Okay. The line that a plumb line makes.
Okay, good.
Right, brilliant.
That's a good start. That kind of matches my definition, so why don't you just use mine from now on?
What, that it's perpendicular to vertical? Yeah?
Look at number 3.
Look at number 3.
Yeah.
Yeah, being led down. Or number 3 on yours.
Yeah.
That's a vertical line. What are you gonna? Well, I can't read it. It's tiny writing. A plumb line at that point. Yeah.
You had no problem reading number 1.
I've never read number 1, have I?
You just recited it to me.
Number 2, the horizontal. Yeah?
You read that one too.
I didn't read number 1, did I? Did you read number 1 in your head and think it was me that read it? Or did somebody else read it to you earlier and you thought it was them that read it to you?
Obviously, you can read them.
I've never read number 1 though, have I?
You had no problem reading any of them.
Right, brilliant. So we've sorted a vertical and we've sorted a horizontal. We both understand what they are. Yeah?
Tell me what vertical line is.
What?
Tell me what vertical line is.
It's the y-axis on a graph, isn't it?
That's not what number 3 says here.
Right, is that the only definition you're ever going to go with? Who's that?
No, but it's the most
Who is
reasonable for this
Where
context.
did you get this from?
Civil engineering class.
All right, class.
Yeah.
Have you been to class?
Absolutely.
Okay. Right, so where are we going to go from here then? We've got a vertical and we've got a horizontal. We've got two
so what's
straight
the
lines.
issue?
Right?
Yeah, sure.
Yeah. So the level surface, which I presume you're going to say is the water, is the...
No, let's just use the definition.
Is the
that we
water
agreed on.
level or not level?
I'm not going to talk if you're going to interrupt.
Is the water level?
Define level.
Horizontal.
That's not what this definition says right here.
What do you say then? You give me your definition of level. I'm telling you my definition. You tell me yours.
Well, let's use the definition that the civil engineers use, since we're talking about civil engineering, right?
I don't know. You give me your definition, please.
Okay. My definition is the same as the definition used for this context, which is surveying still, which is part of civil engineering.
Plain as surveying? Plain surveying?
Surveying.
Or just normal surveying?
Yeah. Surveying is part
just normal
of
surveying.
civil engineering.
Mm-hmm. Yeah.
I don't know what you just said.
Surveying with tools, like a level or a theodolite or something like that. That sort of surveying.
Or plumb. Or plumb, yeah.
Plumb, no, plumb
or a
is vertical, not level.
But it's a surveying tool.
What, a plumb?
Yeah.
Where do they use that in surveying?
Oh, Jesus. What are you talking about? It's just one of the tools that you can use.
I'm asking you where you use a plumb in surveying.
Okay.
Go on.
It's used in all the tools that you just talked about, like a theodolite or a transit.
Is it?
To define vertical.
Why do you need a vertical?
Because you need to be pointing straight up and down.
You don't need to be pointing straight up and down if you're using a level.
No, you'd be horizontal.
You need to be horizontal, yeah.
So you're telling me that you can't imagine any situation in surveying where you have to put an instrument straight up and down?
Well, you tell me. Why do you want me to imagine something? You tell me. You're the surveyor, aren't you?
No, I'm not a surveyor.
Oh, right, okay. So you're just talking about surveying, but not really knowing much about it. Do you know the words?
No, I know a lot about it.
Oh, you do know about it?
Yes.
Brilliant. So
yes,
you've got a surveyor.
What does that mean?
What tools has he got?
He's got a theodolite, he's got a transit, he's got a rangefinder, probably a lot more than that.
Okay.
A prism.
Right. So we've got our level set up. Yep.
What type of tool?
Pardon?
What type of tool was used?
Well, you're telling me. You're the one that's doing the surveying, aren't you?
No, you just.
We're trying to set up and measure the curvature, your curvature of the water level. Yeah.
No, that's you need a water level that's like miles long. That doesn't exist.
What doesn't exist?
A water level that's miles long. No, a bubble level is like 3 foot, 6 foot.
You mean a spirit level?
Yeah.
Right. Okay. Yeah, you can get them. You get a few lengths. You can extend them though. You by having a straight, can't you? If you get a straight edge and then you put your level on top of it, that extends the level all the way along the length of the straight edge, doesn't it?
Yeah, but you're introducing.
Yeah, you don't really do that, though, do you? So, let's say you've got a water level.
Describe this water level.
Do you know what a water level is? Do you want me to join?
Yes, a U-shaped piece of tubing.
A picture. A U-shaped piece of what?
Yeah, it's a piece of tubing in the shape of a U, and you fill it with water.
In the shape of a U. It doesn't necessarily have to be in the shape of a U. It's just a tube, isn't it?
Yes, the tube is shaped in a U. You form it into the shape of a U.
Why?
So that you can see the tops of each of them.
Yeah. Massive tube, though. I mean, how big could you get that tube, do you reckon?
You could get them far apart.
Yeah. How far, do you reckon?
Oh, I don't know.
So, could you reckon you could get like a 2-mile tube?
I don't know. That'd be tough.
That's well, you can imagine a 2-mile tube, though, can't you?
Yes.
Right. Okay. And then if you put the vials on the end of it, then you would have a 2-mile water level, right?
Yes.
Right. And if you filled it up, it'd have water in it, wouldn't it?
Yes.
Right. Now the water level in that tube at both ends would be the same, wouldn't it? The water within that tube would find its level, wouldn't it?
Yes.
So the point all the way between them two tubes of water and where the water is, that would be called a horizontal plane in between them, wouldn't it? No?
You could draw a horizontal plane, but it wouldn't be perpendicular to the plumb. They wouldn't both be parallel to the plumb at the first location.
Sorry?
Okay, let's start with your example. You fill this 2-mile water level up.
Yep.
Right? Okay, and then so you have 2 locations, 2 miles apart, right?
Yep. I'm having a go at drawing this.
Present now. Create a plumb line and a perpendicular level to that plumb line at one location, and repeat it at the other one. They won't be coplanar.
Right, so let's have a look. We've got a water level here and a water level here. And it goes like that. And you reckon because I reckon this would be what it looks like. You tell me where you're wrong. Have you got any way of drawing anything here? How are you? Are you going to come at this blind? Do you have any way?
I could draw it, but
yourself?
easier to just use the pictures I've posted before that you've forgotten about.
There we go. You put a picture in, did you, earlier? Or you just did that with the ones with the words? Yeah. You looking at that now? Is that what you're saying? You were saying they won't be perpendicular to that line.
Correct.
Oh. How would they not?
Because the Earth is a sphere.
Oh. Right, so because the Earth is a sphere, that a vertical isn't perpendicular to a horizontal.
At every location where you define a vertical and a horizontal from it,
Yeah.
the vertical is perpendicular to a horizontal.
Right, but not on that horizontal plane in between them water levels.
You're talking about you draw a horizontal plane between the two levels.
Yeah, well, that's what a water level does. It establishes a horizontal plane of reference.
Yeah, if you did that somehow and you created a thing that you could see that was a plane between them, and then you made a plumb line,
yeah.
You can get one plumb line perpendicular to that, but not the other.
Oh, why is that?
Because of the definitions I posted here.
But it's a straight line, isn't it?
Yes.
But so, because it's a straight line, then why would the verticals? Nicely done.